5 cents might not seem like much, but when it's 5 cents for every cow every day, then it really adds up. New AminoSure XM precision-release methionine provides the optimal combination of cost, feed stability, rumen stability, and intestinal release to deliver the best cost per unit of available methionine on the market today. Learn how at balchemanh.com/findyourx.
Hello, everyone, and welcome to the Real Science Lecture Series. My name is Scott Sorrell, Director of Global Marketing for Balchem. As the dairy industry searches for ways to improve efficiency and reduce environmental impact, keeping cows in a herd longer has been one option studied. Today, we welcome Dr. Ian Lean, Managing Director of Scibus, a livestock consulting firm and adjunct professor from the University of Sydney, to share an in-depth look at the impact we can have if cows stay in the herd longer. Dr. Lean is currently the founder and managing director of Scibus, a leading authority in the health, nutrition, and management of dairy cattle. A graduate from the University of Sydney, he spent 6 years as a large animal veterinarian in the Hunter Valley before undertaking his PhD at the University of California. He actively consults with dairy and beef farms across Australia and has extensively published on the interactions of nutrition with production, reproduction, and health. He has been a keynote speaker at numerous international conferences in the USA, Canada, UK, EU, South America, South Africa, Australia, and New Zealand. He has won many academic and industry achievement awards throughout the world as well. Thank you for joining us today, Ian. You should now have control of the screen.
Thanks, Scott. And probably the first port of call is to acknowledge and thank my co-authors on this, and they include my research director, Helen Golder, Jose Santos, who spent a sabbatic with us down here, Stephen LeBlanc up at Guelph, Todd Duffield, who also did a sabbatic down here with us, and David Sheedy. He's our new PhD student, and he's going to be working on this topic in some depth. So I also want to acknowledge the new project that this comes from, and that's the Dairy Up project, and that's a major initiative down here in Australia, and it involves a number of organisations, but the lead organisations are ourselves, University of Sydney, and the New South Wales Department of Primary Industry and Dairy Australia. So these are the people who have helped me put this together. I guess the first question is, why bother? And really it looks like there's a significant opportunity here to improve the efficiency, productivity, reduce the greenhouse gas intensity of production. If we look at the current structure that we had in this database, what we can see is that there's very few cows, in fact, only about 8.5% coming through to the 5th and greater lactation. So it raises an issue there, because we know that the cows start to peak in their milk at about the 3rd lactation, and they're reasonably constant for the next couple before they start to slightly decline after. If we look at a different structure, somewhat flatter, where perhaps only 25% of the cattle were parity 1 heifers, there's an opportunity here for, just by subtly changing the age structure, to produce about 16% more milk, and we'd also have about 8% more calves to sell, whether they're purebred heifers or crossbreds. And we'd also be allowed to, able to apply a lot more genetic selection potential. So the questions really are, what's stopping us? And what are the downsides? And I guess, one of my cynical friends from California suggested to me that what's happening to the older cows, and he suggested that they were going off to visit various fast food outlets. So we want to secure the industry against the risk and the perception that these cows are disappearing perhaps too soon. And it was very much triggered by some work we were doing in California. And similarly, when we checked out some Australian herds, we were seeing large numbers of heifers coming through. Some of this was an adjustment, I think, for sex semen, but some of it reflects the benefit to bother ratio. And this is a ratio I was taught by a young veterinarian who said that when it came down to studying something, there just wasn't the benefit to bother ratio for the students to look at it. So something might represent a good opportunity, like that 16% more milk, but is it worth the effort? And why aren't producers doing it if it's feasible? So we got two questions. Is this simply a response to good markets? And are we simply taking advantage of the potential to bring through young cattle, remove older cattle? And what is really the nature of the bother? Why were we seeing this very high rate of heifers in these herds? So that's where it came from. So how do we ask the questions? Well, we got together with friends and colleagues to gather about more than 36,000 cows worth of data from Australia, USA and Canada. And these were in carefully conducted prospective studies. So, this was about us doing good studies where we kept the data. It might not have been fit for every purpose that we wanted in this current study, but it was valuable data and allowed us to ask a lot of questions. So we wanted to look at the health, the reproduction, body condition score and metabolism of these cows to help us direct future studies in dairy up to try and figure out what is happening to these cows. Why are we losing the cows? So the key issues we wanted to address were profit, obviously for producers, primarily cow care. We really care about our cows. Achieve social license, and our goal is to try and de-risk the dairy industry business and have happy cows. I don't know how we define happy cows yet, but I know what they are and I want to achieve that. So we hypothesized this, that parity production system, whether we categorize them as pasture-based or intensively fed, milk fat, protein percentage, milk solids production, how that would influence survival, reproductive health and metabolism. And we really didn't have a great database other than for the reproductive data to look at those issues around how milk production influenced the outcomes. So what did our database look like for survival? What we had was about 13 studies, about 33,000 cows. We ended up kicking out the non-Holsteins because there just weren't enough of them. The majority came from TMR situations, whether they were in Australia, Canada, or the USA. And we looked at these key outcomes of hazard not being bred, time to pregnancy, pregnancy to first mating, odds of pregnancy and lactation, the influence of the milk and milk solids, and production and percentage of solids. One of the things that's important and reasonably novel about these studies is some of the statistical analyses. And, at this time of night, if I read this here, I might put myself to sleep, but I'll chance it on the basis that you guys are early in the morning. So we looked at survival analysis models, and we particularly wanted to look at the hazard of not being bred and the hazard of pregnancy. So the probability of not being bred, and we wanted to look at the probability of pregnancy, and we were able to use Cox's proportional hazards models. We also wanted to look at whether a cow got pregnant in a lactation, because the biggest cause of removal was reproductive failure. We wanted to see how these things like pregnancy to first service were affected as well, and we used logistic regression models for that. So we used similar models basically for everything, in that these were linear models, and we used those also for disease and metabolites. And all models evaluated the fixed effects of parity, and we categorized them as 1 to 5 and greater. The production system, but critically, we centered study year, and we centered we nested the random effect of cow within group. And why did we do that? Well, basically, we had a number of studies that weren't just observational, they were actually intervention studies. And you'll see some of the interventions in the subsequent slides. So it wouldn't be fair to actually look at a cow between the intervention groups. So we needed to nest the cow within a treatment group. For example, we might have looked at amino acid intervention. So we nested them within the controls, or we nested them within the treated. So the treated and control groups weren't the same. We also centered the production variables because we wanted to look at the deviation away from herd center. And we wanted to see whether animals that lay outside the mean within that group were different. And this controlled a lot for the effects of time, because a lot of these studies were run over the past 25 years. So there's time and there's also system effects. So we wanted to control for that as much as possible. So the centering within a group was very important for controlling for those effects. The interactions of parity were tested, and we did a backward stepping model. So if we have a look at the ones the studies that were used in the survival database, what we've got are some of the older studies out of Canada. We've got some really recent ones that are unpublished. So it's a mix of studies across time, and you can see that there's a number of different interventions there that we use. And some of the studies are observational. Those couple from Jose's group in California, there's a lot of numbers in those, about 20,000. So they were peak studies that obviously populated a lot of the data here. So we ended up with about 31,000 cows in this group. We excluded non-Holsteins. And this, I think, is pretty telling. The mean for all parities was 2.28 with a standard deviation of 1.46. And it just reinforces the concern that we are losing cows a bit too quickly out of herds. Out of this data, there was about 2,000 that were pasture-fed. The key outcomes were all removals, deaths, and sales. And so what you can see when we look at the Kaplan-Meier survival curve, and this is the proportion of cows remaining on the y-axis and days in milk on the x-axis. And what you can see is that by 300 days in milk, basically there were only about half the parity 5 and greater cows left. And you can see that there's almost a monotonic drop-off in survival as you go through parity. The parity 2 and parity cow ones overlap a little bit, but the parity 3 and parity 4 and parity 5, you can see the difference. It's pretty obvious. The interesting thing about this, though, is that when you start to look at it and you go, well, is it all because we've sent them off to beef? If you have a look at the risk factors here for died and sold, you can see that with parity 1 as the referent group, what you can see is that the drop-off is not that profound for animals in parity 2, parity 3, and parity 4. They tend to be retained a little bit better than the heifers. But when you get out to parity 5, you can see that they're disappearing at nearly twice the rate of heifers. So that there's a pretty substantial impact there around that. If we look down on the next line, though, this becomes even more interesting, because what we find is that in terms of sales, yes, we've got increased sales once they hit parity 5 or greater, but what we're seeing is that the younger animals through parities 2, 3, and 4 are being retained more. So they don't really want to sell those animals. They want to hold them. But when we come to the deaths is truly remarkable. The parity 2 animals are 1.6 times more likely to die. The 3s are 2.8. The 4s are nearly 4. And the 5 and greater is over 4 times the risk of death compared to a heifer. So what we do have here is evidence of a really quite profound change in the risk of dying. So over that period, you can see that the sales and the dying are really very different reasons for an animal leaving the herd. If we now have a look at the reproductive database, this is a little different again, and you can see that we don't have the same studies in the reproductive database necessarily that we had in the other database. So there's different studies with different outcomes that we've been able to put into the different analyses. And that's part of the power, is that we're able to bring all those different studies to bear for different questions. So if we look at the first thing that we wanted to look at, and again, these are the Kaplan-Meier survival curves, so we can look at the proportion of cows on the y-axis, and we can look at the days in milk, and we cut it off at about 120 days. And what you find is that what we can see here is basically parity 1 were a little drop off more than parity 2. So you can see that there's a difference between parity 1 and parity 2, and unusually it's the parity 1 that have got a greater hazard of not being bred. If we look down, we can see that, you know, as you drop off the parities, you go to 3, 4, 5, you can see there's a much bigger risk of them not being bred at all in that first 120 days. These data are from about 32,000 cows, and the parity greater than 5 cows or equal to 5 was 2.4 times greater hazard of not being bred than parity 1 cows. Parity 2 had a reduced hazard than parity 1, so they were in better shape. But parities 3 and 4 had a greater hazard of not being inseminated than parity 1, and a lesser hazard than 5 and 5 plus. If we look at time to pregnancy, it's actually not quite as dramatic as the hazard of not being bred. So if we look at time to pregnancy, what we see is the survival curves again, which is proportion pregnant, so it's like a cumulative proportion going out to day 300. And what you can see with this 33,000 cows is that all parity groups differed in the daily probability of pregnancy, which declined with parity. And we can see that it's not as dramatic. You know, you've got parity 5 cows that have a hazard ratio versus parity 1 of 0.73. So they're about 27% less likely every day to get in calf over that period. So that's the difference on time to pregnancy, which is interesting because it's different to the hazard of not being bred. If we come across now and we ask the question around that probability of pregnancy or the hazard of pregnancy, what we can see here is that this is the predicted hazard of being pregnant on the y-axis and milk yield centered by group on the x-axis, and what we've got is data from about 20,000 cows. All parity groups differed in the probability of or hazard of pregnancy, and parity 1 cows, and you can see for those of you who are into that sort of thing that their risk is 1, so that makes sense. They're kind of the referent group, and they touch 1, and you can see that the risk is quadratic, and it's centered around pretty much the group mean, so that there's not a lot of difference for the cows that are close to the group mean. They're not dropping off much in the hazard of pregnancy. But when you start to get out to the low producers, or when you get into the very high producers, you know, cows that are 20 litres, you know, 50 pound roughly above, you know, the group mean, well, they're starting to really struggle to get pregnant. There's not a lot of them, but you can see the nature of the beast. It's a quadratic response to milk production within group, and it's a really important difference to some of the other ways that people have looked at reproduction and production. One of the interesting things is that we think that milk protein percentage, and this has come up in a number of our studies and in some other people's studies as well, we think that milk protein percentage is a pretty useful indicator of probability of getting pregnant. And in this case, we've got the association of milk protein percent centered on group within herd on their production at approximately 70 days in milk. And this is the relative predicted hazard of being pregnant. And so what we've got is about 8 to 9,000 cows worth of data. But you can just see that these older parity cows, like in the other figure, they're very depressed in terms of production, in terms of getting back in calf. What you can also see, though, is that in this case, the centered percentage, which is optimal, is above the group mean. So in this case, there is a benefit, and we suspect that it may be something like a metabolic signal from these cows saying, yeah, I'm okay to get pregnant because I can spare protein. So I think that it's a really interesting observation that matches a number of others and it's something that maybe we can make more use of in a practical sense. In this case, if we look at now pregnancy to first service, and that's what often people have looked at as pregnancy to first service. And again, what we've got here is a population of about 23,000, 24,000 cows nearly. And what we're looking at is the odds of being pregnant to first breeding. And what we can see here is that the univariable odds show that there's a slight reduction in risk for parity 2, parity 3, parity 4. Parity 5 drop off a little bit, but not all that much. If we look at the milk yield subpopulation where we did have milk, the univariables don't differ much from the rest of the population. So we lose about 1,000 cows, and unsurprisingly, that figure's not too different to the one above. But where it gets quite interesting is when we take into account milk production. And when we take into account milk production, some of the differences disappear. So some of this is being generated by a higher production. And once you control for higher production, then, for example, parity 4 cows really just didn't differ that much from parity 1. So, you know, there's a really interesting pattern here that when you account for milk production, what you find is that the differences are around the parities 2 and 3. So it's kind of a little bit different to the other data we've seen, and a very different pattern, which suggests that perhaps all the variability that exists in the act of insemination and delivering semen is just so great that we lose maybe the texture, or perhaps it's just is that pregnancy is a more robust measure than the time-related measures that we've talked about so far. So if we now look at a metric that I don't know that anybody else much has looked at, the problem really is overall pregnancy and lactation, not so much at first service. And now we're looking at the predicted coefficient of the odds of pregnancy, which is a bit of an odd metric, but all you've got to do is think about those previous graphs and it's pretty similar. And what you've got here is a quite different curve, because there is an interaction with parity 1, and parity 1 animals are just shifted off to the side to the others. So they're more centered around the group mean, and they tend to be also a little bit more peaked. So the optimum is tighter in terms of risk for those parity 1 animals of not getting pregnant in a lactation. And you can imagine that poor producing heifers, they're going to go, and they're not going to be tolerated too much. And the question then becomes, why are they lower producing? But this data at least gives us a heads up that they're being removed as we'd expect. And again, they dramatically drop off with production, whereas it's a more subtle drop off with production for the others. And what you can see is that, in fact, that the animals here are optimal above the group mean by about 10 to 15 litres. So, you know, that's quite a difference. You know, we're talking about 30 to the high 30s of pounds of difference, so that the optimum is actually quite high for the odds of pregnancy and lactation. And what it means is that lower producing cows seem to have more probability of not getting pregnant, as well as the higher producing cows, and these are quadratics. So all parities differed, parity 1 having the greatest odds, and parity greater than 5 the least odds of pregnancy and the lactation. So interesting. Even though heifers are slower to get bred up front, they were more successful in getting bred. And being near the average production, or even well above, improved the probability of getting pregnant in a lactation. So despite similar pregnancy at first service, increased parity resulted in increased failure. So if I summarize the reproductive stuff, what we've got is, if we look at the hazard of not being bred, we've got production as a quadratic effect. Fat percentage is a negative linear, and fat yields are negative linear. Protein's quadratic, protein yield is quadratic, and milk solids yield is quadratic. If we look across fat percentage, generally increased fat percentage tends to give you grief. You know, it's either a linear decline or a quadratic decline, depending on what you're looking at. So time to pregnancy is linear, pregnancy to first breeding is linear, pregnancy and lactation's quadratic. If we look down the others and think about them, milk's generally quadratic but linear. The fat yield is pretty similar to fat, but it's mostly linear. So it's a linear decline with increased fat yield. And that's not surprising, because one of the meta-analyses we've published in Journal of Dairy Science shows a profound effect of fats on fertility. So there's no question that fats are a very pro-fertility intervention. Protein percent, quadratics, and we've seen some of that protein yield, and down to milk solids yield, which is the combination of fat and protein. So I think the summary of reproduction is pretty simple. It was the biggest source of removal in this study. In general, increased parity reduces reproductive performance. However, the performance wasn't that different at first in SEM. So it's a failure to being mated and ultimately not going in calf. Both low production and very high production are risk factors, and production only has a small effect on pregnancy at first in SEM. And the good news is we do have nutritional, as in the fats that we just talked about, and hormonal methods to improve reproduction. So there's ways and means to improve reproduction. Now I want to look a little bit at the disease information, and I want to look at the disorder. And I thought I knew this stuff, and this has been pretty challenging for me, and it's really highlighted that sometimes we have inherent knowledge, and that inherent knowledge is okay, but it's far from perfect. And when I look at this data has really challenged me. If we look at milk fever, for example, or clinical hypocalcemia, as we probably should call it, the incidence was only 0.1% for parity 1 animals, but for parity 5 plus, it was 13%. The odds ratio for milk fever or hypocalcemia, clinical hypocalcemia, is 100 plus the odds of parity 1. Even if we take parity 2, it's 20 times the odds. This is a profound evidence of problems with hypocalcemia in the higher, older age group cows. It was a pattern that was somewhat similar across, for example, retained placenta. The odds ratio there for 1v5 was 2.3, and it was a monotonic increase in risk of retained placenta. If we look at ketosis, and we look at the risk of ketosis, well, what we've got there is we've got 4.9 times the risk for parity 5 plus. So a very big increase in ketosis. Lameness is 5.6, mastitis 2.5, not as dramatic as I thought. I thought perhaps mastitis may be more dramatic than lameness, but in fact it's lameness that's the real player. If we come back and look at some anomalies in here, what we've got is dystocia, as you might expect, is higher in the heifers. But what's surprising is the monotonic decrease in risk of metritis. Who'd have thought that metritis would decrease when you've got retained placenta increasing? You've got evidence of other metabolic dyscrasias like ketosis, and they're showing that they're increased. So one of the interesting things about this is that it doesn't entirely fit with the inflammation hypothesis. Some people are suggesting that, it's really inflammation that sets the agenda around, the problems of periparturient disease. And I have absolutely no doubt that some of that is correct. I very strongly support that hypothesis. But I think to ignore the calcium axis, where calcium is involved in the integration, or bone is involved in the integration of energy and protein metabolism, is probably to overlook a substantial part of the risk factors. And what is really challenging is to try and understand why these animals are changing so dramatically in their inability to control some of these diseases with parity. So it's been a long time since anybody really looked at parity in detail. Certainly there's really good studies out there where they have looked at parity in reasonable detail, but the last time that these things were done was back when Dehu and Martin did this in about 1984, and a very good clinician from Israel Marcusfeld also looked at these things around that similar time. But there's not been much looking at the effects of parity in the last few years. If I then go back and have a look at this data for you so that you can see the numbers, and it's a bit of a busy slide, so I'm going to apologize for the busy slide. I didn't compare the odds for clinical hypocalcemia to parity 1. I compared them to parity 2, but the effect is dramatic enough. By the time they hit the 4th parity, they got nearly 9 times the risk of getting clinical hypocalcemia and 20 times the risk that they would have had in parity 2. As you can see, the increase in mastitis risk is monotonic, and we'd expect that. There's a lot of reasons why mastitis risk should increase. The first and foremost of those is simply exposure to milking machines and humans milking them. But the lameness really surprised me. In most studies, the metric for lameness here was a treated cow. So the lameness, again, increases quite dramatically and monotonically, and much more than I thought. I certainly wasn't quite as alert to how much lameness there was in terms of the older cow. We look at dystocia. Dystocia, as I said earlier, reduced. Retained placenta, again, increases monotonically. Metritis, again, you've got a marked reduction in the risk of metritis to parity 1 animals. And I guess if I was looking for an explanation, I might suggest it's the trauma of an initial birth. Endometritis, though, the sequelae perhaps to metritis, it was pretty static. Little bit of a reduction compared to parity 1. Displaced abomasum, you might have expected that in the increase with age. Clinical ketosis, I'd argue often that clinical ketosis is simply people identifying animals with other disease that then have high ketones. But what you can see there is a monotonic increase. Subclinical ketosis, not nearly as dramatic as clinical ketosis in its increase, but increased. And respiratory disease, we actually thought that heifers would have a higher rate of respiratory disease, but that's not so. So a little bit there in terms of those disorders, and certainly some challenging thoughts about how they happen. We didn't have as much data. I think there's only about 7,000 cows in this data set on metabolites, but it is across a number of different countries. So it's cool in that regard. That there is one uncool factor about it, which is that the peak milk samples were mostly done in Australia. So you got to bear in mind that you shouldn't do a direct comparison around time to time to time unless you know that you should be cautious about that. But looking at the glucoses are dramatically different for the different parity animals at the different times. And what you can see is that the drop off there is really quite remarkable for the at calving, where parity 1 animals tend to be quite high, and the parity 2, which incidentally mobilise the most body tissue, as we'll see later, that group had the least glucose. And again, the difference here is millimoles per litre from the group centred mean. So when you look at it, you know, there's a nearly a 4 millimole or a 5 millimole difference for the parity 1 versus parity 2 at calving. So, you know, that's really quite a dramatic difference. If we look at the NEFA, the non-esterified free fatty acids, what you can see here is that there is a really dramatic difference over the parities. And what you can see is parity 5 and parity 4 are mobilizing a heck of a lot more NEFA. Now that's really interesting because the body condition score and body weight data I'm about to show you that almost argue they shouldn't be able to do that. But they're mobilizing more NEFA. That's in response to probably those lower glucoses. Remember, blood glucose is held under very tight homeostatic control. So lower glucose probably reflects quite a serious problem because, you know, you'd expect that glucose to be held very tight, but you'd expect the NEFA to show us more response, and they do. So the NEFA are lower in the first and second lactation animals, parity animals. You can see that the NEFA are higher across the board for the older animals. So really quite marked increased reliance on mobilized fats, and that's reflected obviously in the much higher 3-hydroxybutyrate concentrations in the older animals. And these out here on the right are the parity 5 and greater, going to the parity 1 on the left. And what you can see here is a really striking difference in the ketones. And what this raises for me is concern, because many studies have only evaluated parity dichotomized. They've looked at primipars and they've looked at multipars, and then they've controlled for that factor. But if you don't control for the animals that are really aberrant in those groups, which is the 4s and the 5s, you're going to get a really big potential to confound observations and draw wrong conclusions out of your data. Because those animals that have got those high 3-hydroxybutyrates are the same animals that are having problems getting back in calf, and they're the same animals that are going on to have greater risk of death. So when you start to talk about, an association between blood 3-hydroxybutyrates and outcomes, I think you've got to be doing some really tight control on the parity before you can be confident. I find cholesterol to be a really interesting variable. We've found many times now that it's highly related to reproductive performance. And interestingly, what you see is low cholesterols in the parity 1s. At peak milk, they're really dropping quite low down. What you can see is that the parities 2, 3, 4 seem to have their blood cholesterols maybe in a better place. I wouldn't put too much predictive value on that, but I just find it interesting to see that pattern of cholesterol in these animals. And here's the one that really, I guess, shouldn't surprise anybody after the hypocalcemia, clinical hypocalcemia results. And here's the younger animals able to control the calcium concentration far better than the older animals that are really dropping away. And the interesting thing is that they're even dropping away at peak milk production. So the blood calciums, again, which are held under tight homeostatic control, they're still falling when we're talking about peak lactation, let alone in early lactation or at calving day. So a summary of longevity and metabolism. There's differences in survival, and they're more likely to die. They're at greater risk of removal overall. There's marked differences in concentrations of metabolites for cows of 5+ parity, 5 and 5+, that are reflected in the differences in disease. The disease outcomes are consistent with the metabolic observations. These marked differences in death and concentrations of metabolites with parity. Basically, they're at all times evaluated are consistent with the reduced reproduction, health, and body condition. The findings demonstrate the considerable risk of confounding in evaluation if simple cut points for parity are used to diagnose subclinical disorders. There's a need to use parity-controlled models with greater complexity, i.e. not simply nulli and multipluriparous, to better understand older cows and the changes in metabolism that are associated with age. Critically, this leads us to start to think about what do we need to do to modify these risks. So that's where we need to be, is thinking about modification. So the last bit of data I want to show you is one that I guess we've had our grad student, Dave Sheedy, working on, and Dave's paper will be coming out very soon. So if we look at body condition score across parity, what we can see is that, and again, these are centered to the group mean, but what we can see is that on the left axis, pre-calving, these animals are, about 0.2 body condition scores higher on the 1 to 5 scale, the Edmondson paper. If you look at them drop down, they're dropping down to less they're dropping down about 0.3 of a body condition score compared to the group-centered mean for parity 2. So the parity 2 cows are really dropping body condition score. I think most clinical nutritionists and veterinarians listening to this will know that inherently, but it's kind of nice to see. There wasn't a lot of difference in production system, but those on total mixed rations tended to come from a higher base at peak milk body condition score and then drop down to a lower base at peak milk body condition score for parity 2 cows. So there was a bigger difference in the TMR parity 1 to parity 2 than there was in the pasture based herds on that. And change in body condition score, basically, you can see it going monotonically across the parity groups. So the last graph to the right just shows it declining all the way. So Dave, kind of loving graphical presentation, came up with this graph, and I got to confess, I don't love this graph as much. So you're going to see this two different ways. But what we can see is that this is what's called a waffle graph. And there's 4 groups. There's low body condition score and low body weight, which are the blank squares. You got low body condition score and high body weight, which are the black squares. You got high body condition score, low body weight, which are the orange squares. And then you got high body condition score, high body weight. So what we did was we created a cut point based on the centering, and animals that were above or below the mean were divided into those groups. And then we put those categories together to create 25% should it be in each category, right, of any particular parity. But what we can see with parity 1 is that we got a lot of orange squares. And those orange squares mean that they've got a high body condition score and low body weight. No surprise about the body weight. If we go down to parity 5, though, we see lots of black squares and very few orange. And by parity 5, and you can see the change across the different parities, you're going to a low body condition score cow with high body weight. So that's a bit of a problem because there's 61% parity 1, high body condition score, low body weight, and 56% parity 5 or greater, and they're low body condition score, high body weight. So I kind of find this graph a little bit easier to see. But the other thing about this graph is that we thought, well, let's have a look at the other breeds. We didn't have masses and masses of other breeds, but we had enough for you to have a look at. And you can see the same pattern. And right here in the middle is the contrast. You got low body condition score and body weight, and you got high body condition score and high body weight. And if I could find the marker, I would do that, but that's okay. So the high body condition score, high body weight, you can see that what's your high body condition score, low body weight, you can see that parity 1 have that dominantly, and you can see parity 5 with very little, and you can see it's the exact opposite for low body condition score and high body weight, and you can see the same pattern for the other breed cows. So it wasn't just the Holsteins, it is a more general condition across the other breed cows as well. So what do we do now? I guess pretty simple. We need to define and improve. We've got strong evidence of impaired metabolism with increased parity. In order to fix it, we need to have better define the causes, but we've got plenty of solutions. We've got ration balancing, better protein nutrition, better fat nutrition, some reproductive treatments that benefit fertility. Where will we look? We're going to look into the metabolic aspects of protein, nutrition, particularly rumen function, calcium and bone, cholesterol and fats. We want to know, why do older cows lose body condition score? What's this mean in terms of reproduction and health? And we're also interested in facility design and management to help, because if we ignore those, we miss some of the big picture. So I'd like to thank you all for attending. I'd like to thank my collaborators, past students. They've contributed a lot of those data sets. My colleagues in Dairy Up, and it's a big group of colleagues and a pretty exciting group. The corporate and public good supporters of the research are included in the original studies. without the support of the corporates, we wouldn't be able to provide these sorts of data. Those studies are very important, not just for examining an intervention, but providing important data to look at the controls as well. So thank you.
Well, thank you, Dr. Lane. Before we get started answering questions, we'd like to share a brief video, and then we'll be right back to answer the questions submitted during today's presentation.
Every expectant mother knows that what she eats impacts her baby. And now research shows that is also true for our cows. Maternal consumption of ReaShure during late gestation had a positive effect on the in utero calf, setting her up for better health and potentially even higher milk production once she joins the milking string. Learn more at balchemanh.com/launch and launch your herd for life.
You can still submit questions through the Q&A tab at the top of the screen. Dr. Lean, our first question comes in from, let's see, which one I want to go with? Meta. Could the large increase in lameness explain some of the loss of body condition score in older cows?
Yeah, that's a really good hypothesis and well worth looking at. Absolutely, it could explain some of it. I don't know that it's going to explain all of it because the prevalence wasn't that high, but we would have understated the prevalence because what we were doing was assessing the treated animals, and as you know, many of those animals may not be recorded, and those more subtle lamenesses of the 2, 3, 4s may not have made it onto our screen. So I think it's a reasonable hypothesis and certainly one we should have a look at.
Very well. Next question comes in from Jose. Thank you for the many questions, Jose. By the way, we'll try to get to all of them. Should we optimize close-up and fresh cow rations based on older cows and not based on average parity of the dairies?
I think we need to know a little bit more about those older cows in terms of their response to treatment. I guess we've done an awful lot of work on those transition cows in terms of research and practical application. And I am not quite sure how profound the difference in response to treatment is. So that's something we should really have a look at too. So you guys are giving me lots of good ideas. I love that.
They usually do. Next question comes in from someone identifying themselves as Peter DVM. It seems that the culling decisions could be being driven by replacement heifer availability. Does the desire to keep the replacement heifers in the herd force dairies to cull older cows?
I think, beef prices in the US were pretty good. And I think that there was definitely a tendency to take some cows out in recent years that may be, let me say, marginal. And I think this comes back to this benefit to bother ratio. And if producers understand these risk factors better than those of us who advise them, perhaps there's an issue there where they're saying, if that older cow starts to look a little bit wobbly, I'm going to take her out. Beef price is good. I've got a good young heifer coming in. That could certainly be part of it. But I think that's why I hovered a little bit over the difference in the culling and the risk factors and the death risk factors. Because, the death risk factor is really dramatic. And the culling risk factor was not so dramatic until you got to those older cows. In fact, they were trying to hang on to the 2, 3s, 4s, weren't they? They had a lower risk of being culled than the ones. So, to me, I think that's part of it. But, the data ran over a long period, and certainly over the long period, beef prices weren't that good for our cull cows. So I don't know that it's, the full story. I think it's part of the story.
Mm-hmm. Makes sense. Jose has a couple questions related to hypocalcemia. The first is, did you consider the issue of hypocalcemia and the dairies with preventative treatments like anionic strategies like liquids and other similar during the close-up period?
Sure. a number of those studies were studies done with to look at transition diets. So one of the large Australian data sets was just that. It looked at the close-up cow. And another one looked at the effects of calcidiol. So 2 studies, I think, we had for calcidiol in that data set. So it may have even been 3, actually, come to think of it. And we had another one from Wisconsin, Megan Connolly's work with Laura Hernandez. So some of those cows are in there as well. So, yeah, we definitely looked at it. And it was part of the reason that it was really important the group center those cows. Because if we had those cows with an intervention in the same group as the controls, that would have been a pretty messy approach.
Mm-hmm. And then the follow-up question is, do you think that by solving hypocalcemia challenges, that will fix also the secondary ketosis and some peripartural immunologic issues? Getting tongue-tied.
Yeah, I think that's very real. There's a couple of things that are worth thinking about there. We now know that bone is really metabolically active and really important through links between osteocalcin and IGF-1. So we found that in the studies that we did in Florida with Jose Santos, and we know that linkage is really strong. And there's other evidence about that from particularly human work. But it now looks like we need to think about how we fix bone. And we need to think about why those animals are still not able to be in full control of their calcium balance, even when they're at peak milk production. And there was older work to say that it takes up to 230 days to replete calcium in the bone. So the question then becomes, well, what's our modern cow's repletion rate like? Can we simply replace it with limestone? Is it available enough? And, there's a raft of questions that come. So, Jose, you're thinking along the right lines. There's a lot more to do there. I think if we can do it, I think it'll be one of the helps to unlock the key. But, if I think about it a little bit too, we're asking these animals to perform at an incredibly high level. Now, for the Americans, you won't know about this, but currently the British Commonwealth is having its Commonwealth Games. And so there's a bunch of athletes there that are working really hard and well above maintenance. Now, our cows are running now 5, 6, even 8 times maintenance. So they're above Olympic athlete performance. And that has got to have a metabolic drain potentially around maybe mitochondrial function as well. So there's a number of areas we've got to think about, really quite intensively to start unpicking this. So any single solution won't be the solution. There will be a series of different solutions to modify immunological response, whether it's through antioxidants or, methyl donor help, whether it's through, vitamin D and those metabolites, or whether it's through negative decad diets controlling and enhancing performance around parturition. But all of those things are going to be brought into play.
Very well. Just want to acknowledge also you got a shout out from Dr. Mike Hutchins. He's appreciative of the amazing data. So he's appreciative of the job you
Cheers,
did here.
Mike.
Yeah,
been a long
cheers for
time
sure.
since we toured together.
Yeah.
He's a great colleague.
Yeah, he's a great ambassador for the industry as well. Dr. Sanderson would like to know, curious if the relationship of pregnancy to percent milk protein was stratified by level of milk protein and use of supplemental amino acids.
No, we didn't stratify by the supplemental amino acids, but we did have one amino acid study in the data set, and that was controlled for by centering for the controls and treateds. In terms of the milk protein percentage, we used it as continuous variable. We did not stratify.
Okay. Next question. Are there individual herds that have more uniform levels of culling and death loss between parity, and what are they doing differently?
Yeah, that's a really good question, and I don't know the answer. But I suspect they'll be out there, and they're going to be pretty valuable to find, aren't they?
Yeah.
Because they may give us some hints. You know, that's a really good thought. So the difficulty is having quality data sets, as you guys probably, most people on the podcast will know. It's very hard to get quality data about removal, and so that's really what we're prospectively going to do with the study that Dave will be working on over the next few years. So we will be looking at that sort of data to try and really characterize what might be going on in a series of different herds.
Mm-hmm. All right, next question comes in from Marcos. Why does parity 2 lose body condition score pre-calving?
Yeah, we've always talked about the sophomore slump. As long as I've been around, it's been a factor. I think it's adjustment. You know, I think you've got one big adjustment as heifers come into the herd, and these herds would have been all mixed. Some would have had heifers as a separate string. A number of our big herds certainly had that, but some of them had the heifers in with the cows. So the heifers have that adjustment. But then I think that the demands of increasing lactation, having come through your first lactation, I think those things really do play on the capacity of the parity 2 cow to compete. So I think it's primarily a competition issue, but it may be that as the change in metabolism occurs around that second lactation and they really start to step up on the milk, maybe the adjustment isn't there at the same time as they're growing still. You know, those animals gained about 130 kilos over that, 130 pounds. They gained about 50 kilos over that transition between lactation 1 and lactation 2.
Next one comes in from Reza, and it has to do with one of those last slides you showed. How to explain the thesis groups in according to biology: high body condition scores and low body weight, low body condition scores, and high body weight.
You know, I just kind of missed the intent of the question there, Scott.
Yeah.
Can you just run that past me?
Well, I just think they're looking for some clarity and some understanding of the interplay between body weight and body condition scores.
Okay. So what we did in that data set was we basically took the mean of the group, and then if they were below the mean of the group for either body weight or body condition score, they got coded into a low group for body condition score or body weight. And if they were above it, then they got coded into the above. That gave us 4 categories effectively. But it's really important to understand that these things do not measure the same thing. At its best, body condition score is a tool that we can use to look at labile tissue. And it's the visibly labile tissues that we're looking at. So if we're looking at an animal that is higher in body weight but lower in body condition score, if it has lipid reserves that it can mobilize from abdominal fat, then it's still got fat it can mobilize. And maybe that's where he's wondering, how could these animals that are in lower body condition score still be the ones that are mobilizing the NEFA? So I think that might be the nub of the question. Certainly, you know, observing these higher producing older cows over a long time and looking at them, there's no question that they're definitely lower in body condition score, and their protein mass seems to have been dissipated. Whether they're able to partition energy into different stores, I don't know. These are the things that would be really worthwhile looking at. There's not a lot of dissection studies on cows at all, understandable. But, you know, that sort of data to look at where the pools of labile tissues, whether they're, you know, the proteins, whether they're the fats, or whether they're the more labile other forms of energy such as glycogen, they're important. And the other thing that's important is to understand the labile stores of minerals as well and vitamins, so that there's more detail we need to understand the makeup of that cow as it comes into calving.
Yeah, makes sense. Paul would like to know your thoughts on the potential of genomics for improving cow longevity.
Yeah, there's been some work. Actually, one of the groups we're working with because of the Dairy Up funding is the group down in Melbourne led by Jenny Price. And they've just published a couple of papers on this. There's no doubt that the genomics is potentially there to use, but I don't think that it's going to be a really substantial part of our ability to manipulate these things. I'm sure, as with genetics, provided we target the right animals, we will make good incremental gains over time. But I think our big gains are going to be environmental.
All right, very well. I saw one here. Hector would like to know if there's a relationship between the data and the feeding standards. So people that I think are using the NRC, the ARC, or Cornell. Did you look into that at all?
Yeah, that's an interesting question. We're hoping to look at a little bit more time series data, looking at relationships between feed composition and performance under different conditions. And that's one of the things that we're going to try and hook into. We did do some work with the herds in California and South Dakota that we had time series data on. And what we found was that some of the relationships that were there, at least in the time series data, haven't been really well described. So things like indigestible NDF appeared to have effects on performance over weeks. And what that does is they may be spurious results, it might be just an association. But there's certainly, I think, more to understand about the way we feed our animals. And it's challenging because we're not being funded as a group of scientists globally to do as much basic research into the performance of these animals. And there's techniques that we now don't have access to. So, there's a real need to drill down to the next level around the nutritional standards. And unfortunately, I don't think we're making quite the progress I would have liked to have seen over the last 20 years.
Very well. I know it's getting late your time. What time is it? Wednesday there yet?
Yeah, it's 1 a.m.
1 a.m.
It's kind of like presenting at Dairy Science. You're presenting at 3 o'clock in the morning, but at least I'm not jet lagged as well.
Well, listen, we appreciate you spending some time with us this morning. I'm going to leave you with one last question because we are at the top of the hour. This one comes in from Alex. Is a relationship between calcium and parity related to bone density? And is there anything we can do to prevent this in older cows?
Well, I think that we need to definitely do some research around this. We've done a lot of work on the transition. And the transition nutrition is so much better than we used to have. But that bone density, I suspect, is a real issue. We don't have a lot of data on bone density of older cows, but it's certainly something that we should be doing. And I would suggest that he's very much on the right track, at least in exploring the bone density issue. The second part of the question is, what can we do? And until we define it a little, I'm not sure we should dive in and try to fix it. My suspicion is that it'll be possibly even more about things like the protein axis rather than the calcium axis at this stage. But, we need to know whether these animals are able to regain that bone density, especially when they're working as hard. When they're cranking out 150, 180 pound of milk, that's a hell of a lot of calcium going through. That places a lot of pressure on the system. And interestingly, when we looked at some of the diets across the research we were doing over in the States, I was surprised that some of the higher producing herds weren't giving sufficient calcium. So, things can easily fall off the agenda, right? And, it's up to the nutritionists and all of us who work in that area to try and make sure we do pay attention to those challenges and make sure we formulate the diets as well as we can.
Well, I want to thank you for a very interesting conversation and presentation, Dr. Lean. Also want to thank everybody for attending today's webinar. If you have additional questions, please submit them to anh.marketing@balchem.com. The Real Science Lecture Series of webinars will continue in 2 weeks when we're joined by Dr. Joe Pagan. Joe is a president and founder of Kentucky Equine Research and will present a presentation titled Recent Developments in Performance, Horse Health, and Nutrition. Our ruminant topics continues on September 6th when we're joined by Dr. Mike Van Amberg from Cornell University. Mike will review the key updates to the latest version of the CNCPS that practicing nutritionists they need to know. Also, plan to join us on November 15th when we welcome back Dr. Temple Grandin to share her insights into animal behavior and autism. Visit balchem.com/real science for more details and to register for all future webinars. Balchem's podcast series continues to offer a deeper dive into our webinar topics. Log on to your favorite podcast platform or visit balchem.com/podcast. We recently shared 3 installments highlighting the newest research from the ADSA. We're closing in on our 50th episode, so there is a wonderful library of topics to choose from. Subscribe to the Real Science Exchange, send us a screenshot along with your address, and we'll send you a really cool Real Science Exchange t-shirt. On behalf of Balchem and Dr. Lean, thank you for joining us today.
Thanks all.